I'm going to show you a typical Wi-Fi decoder installation in a typical HO scale diesel locomotive. For today's demonstration, I've chosen a Rivarossi HR2528 General Electric U25C unit, and so we will try to install this decoder in this. I believe this is DCC ready. Let's open it up. So I have already removed the couplers and the 4 screws. Just need to take the shell off now. It's brand new. Still have the styrofoam here. Alright, there you go. So yeah, it's DCC ready, and you can see this pin connector which we'll need to take off because I just don't have this number of pins plug here. So my decoder is 8-wire NMRA plug compatible. I should say sort of compatible because my lighting wires do not actually fit into the current and voltage that is DCC that is used in DCC. But my other 4 wires, the 2 motor wires and the track power, they can actually straight go in, and I can just wire the lights manually. I just connect the wires directly, the lights. But it's not gonna work in this case because I can see that if I place it on top, I won't be able to close the shell. So actually I'll have to take this board off and then wire everything together. So but at least we know which wire goes where because they are color coded just like the DCC. A special note about the lights. Now usually what I would do is sometimes I would if the locomotive contains like light bulbs, I'll have to replace them with LEDs, and in this case they already have the LEDs in here, so I am gonna try to use these LEDs. So what I will be doing is just finding out the polarity of the LEDs and then connecting the wires appropriately. So to do that, the only difference actually between the DCC decoder and my decoder in case of lights is the connections are reversed. So this runs on like a high 15 volts, and this one runs on a lower voltage. But the common in the DCC is the provider, the current provider, the source, and the current sinks into the blue the yellow and the white wires. So the blue provides the current, the common, and these two sink the current. So LED positive connects to this, and the negative connects to this after the resistors. So now I don't need the resistors in this case because resistors are on board on this. So I just need to wire up the LEDs. So I just need to find out the common which is connected to the LED actually will connect to, for example, this is rear, so this would connect to the yellow, and the common over here would connect to the white, and the yellow of this, which is actually black here. So the yellow which would connect over here and the white, they would actually be joined together to the blue here. So I've soldered the common wire of DCC to the yellow wire, and I've connected these two common wires of DCC over here, and I can directly connect them to white, so I did not attach any other white wire here. Now let's find the blue wire connections, which would be the yellow wire of this and the white wire of this combined together. So let's do that. So you can see I've wired up the motor wires and the track. So I took off the left track wire from here and the right track wires from here and connected them to the red and black, and the motor wires I disconnected from here and connected them to the orange and gray wires here. So now the only wires are left are the light ones for the LED lights. So I'm gonna now take off the board and just make sure that I'm making the right connections. So let's do that. So here I have finally made all the connections, as you can see. Uh, so just to reiterate the note about the lights. So I have basically reversed the connections as I have said before. So the common that was here was connected to each of the lights, either front or rear. So wherever it was connecting to the rear, that became the yellow wire. Wherever it was connecting to the front, became the white wire. And whatever the white or the yellow wire would have been coming from the front or the rear lights, they become the blue wire in my case. So they kind of connect to the common ground, and that's the only difference. And the resistors are on board, so we don't need anything else, and this is not required anymore. So it goes, and let me just fit it all here, and then get back to you, and then we will do a test run and see how it goes. So here we have the decoder installed. So I'm gonna just pop on the shell, and we'll go for a test run and see how that looks. Okay. So here we have this ready. I put back all the screws and the couplers and everything, and I'm ready to test it. So the test track here I have is about 16 volts. It uses a computer power adapter, just to supply plain DC to the track. And here I have, before I run this, I want to mention I have this Walters train line GP35, I believe, and this is Fairbanks Baby Master, and this is Amtrak from Cato, and we have Bachman Norfolk Southern. So all these have been fitted with Wi-Fi decoders, and they all run fine. So let's run this loco. So I have this uh, app in front of me, so you can see. So I'm gonna launch the app, and it says you can enter your engineer name. So basically, this these locos can be controlled, with multiple engineers. So each one can control multiple locos. We'll see in a bit like how. So you just enter your name. I've entered engineer 2 and say okay, and tries to get all the locomotives on the network. So I've already added this locomotive to the network, but if you were to add a new locomotive, you just say add loco, and you will see the newly placed loco on the track, and you say connect to your Wi-Fi. You just need to enter your Wi-Fi password, and you will see it in the list of locomotives here, so which are connected to your network. So this locomotive has a name of Loco 11045. I'm still improving this app, so in future we'll be able to add your own names for the locomotives. So I'll just say manage, and click on the locomotive. So here I have the dashboard. So these are the speedometer, the RPM, the throttle bar, horn. Well, as you know, I mean, you must have seen it in the video while doing the installation, that it comes with sound. So it's not like an option or something you have to pay separately and throw out your old decoder. I mean, it just comes with sound, and I don't know if I showed you. You can probably go back and see there is a slot for SD card where you can actually load your own sounds and just plug it in. So if you need to change sounds for your locomotive, you just take it out, put the new sound, and just pop it back in. So let's start this locomotive. So this is just a sample sound I kind of downloaded off the internet. So I still have to get the licensed sounds and the official sounds that would actually work for this locomotive. So that is still a work in progress. Let's see. I'm just gonna try to show you this front light works. Same goes for rear lights. I'll just keep it off for now. His bell, his horn. So looks okay so far. Let's give it a test run. So I have created like 8 speed notches here. I will in future I'll add like option to make it configurable, so you can fine tune your speeds. By default I've set it in a way that first speed notch will give you about like 5 to 10 miles an hour. Again, that's configurable depending on your incline, how much load you are pulling, and those kind of things. So that's coming soon. Let's just give it one notch and see it run. It's stopping. So let's go in reverse. So that's the test run. So looks okay. The installation went smooth and no hiccups there. So in future, if I do some more videos on decoder installation, I will let you know. Right. Thank you.